Okie dokie. So if you're ready, I would suggest that we start now. This is the workshop from Eckart about his Snap extension SciSnap for science and math related projects. And Eckart recorded a video that I will now share from my screen, and then we will pause in between to follow along with the steps. And if you have any questions, feel free to ask them in the chat or to unmute yourselves and just ask them. Maybe not while I'll play the video, but afterwards. Okie dokie.
Hello, welcome to the SciSnap workshop. I will just briefly say something about SciSnap, then redevelop an example and introduce some others for you to work on. SciSnap is essentially a collection of libraries for various fields such as mathematics, data and database queries. In addition, there are sketchpads for image processing, diagrams, neural networks or graphs. In most cases, there are blocks for corresponding standard procedures, such as breadth first and depth first search, routing, clustering, numerical mathematics, or to teach a neural net. Currently, there are 268 new blocks and a script of 120 pages. Since it is difficult to place so many blocks in Snap, there's a possibility to create, hide or delete categories. The blocks for this can be found in the looks palette. In order not to lose contact with the current Snap version, I did not create a fork, but only modified the current version slightly to produce place for SciSnap. To do this, create a starter file. After that, you can load either SciSnap or existing projects as usual. So now we have a look on the front page of the script for SciSnap with different examples from different fields. And here are the blocks of the looks palette to manage categories. You can add or hide or delete categories. You can import a library to another category and so on. SciSnap has two little helpers. This is Hilberto, he is a mathematician, and this is Alberto. They told me they are relatives of Alonso. I don't know whether it's true or not. And here is a diagram which shows how the sprites are configured to sketchpads. We have, in this case, an image pad. An image pad has a custom as other sprites. And it has a data array, my data, and properties. Predefined properties. You can change them, but only if it's necessary. And to this image pad, you can import data from different sources, from image files, text files, queries, and so on. And you have blocks which work with this sprite. And this is only possible if the sprite, any sprite or the stage is configured as image pad, plot pad, neural net pad or so. And I will show you how this works. Now I want to show how to start SciSnap. If you get the SciSnap .zip file, you can unpack it and you will find all the libraries and two other files, the SciSnap starter file and SciSnap, an empty project of SciSnap. And here I loaded the actual version of Snap and I put the SciSnap starter file and drag it to the Snap window. Now I see Hilberto and comment that I should activate JavaScript. I'll do it, and then I start this button, and we have a lot of new categories here in the palette menu. and I can load SciSnap project or anything. In this case, I directly drag SciSnap, an empty project, to the window, wait some seconds, and now I have a window to work. If I have a look in this, I have a math palette with different libraries, a plot pad to plot graphs and function graphs and so on, data, an image pad, SQL for database queries, data manipulation, a graph pad with nodes, edges, a neural net pad, and because here's some space, I have extra category for my blocks. Now we can start to work. Now the first example.
Okay, so this was the first part of the video, and we now want you to get started with SciSnap. So Eckart provided some links that I can just post to the chat. So this is the link to the YouTube video if you want to check that later. And also this is the link to the files that you need to download. This is the link to the script if you want to explore things further. And there was another one link. Right, this is the link for the workshop materials with also the final project solutions. Okay, Eckart, I would now unshare my screen and you can maybe walk the participants through the setting up process again with your screen sharing.
Okay. As far as I see, Jens has a wonderful new version, and the first steps from the video are obsolete in future. And I tried it out this morning. It works wonderful, and I don't think we need.
We can't hear you anymore, Eckart.
Oh.
Can you?
Oh.
Oh, now it sounds.
Now we can
better.
hear you again.
Yeah.
But a little bit low.
Yep.
Yeah.
One, two, three. Is it better now?
Way better.
Totally.
I can't hear you.
Can you hear me now? Oh,
Please say anything.
In. Yep. Can you hear us? I'm saying something.
Hear anything.
To be or not to be.
But if you.
Should we say? Say something.
Can you say something?
Hi, Eckart.
Okay, I'm a teacher. I'm used to talk for alone and the rest is sleeping. And I do it now. As far as can see, Jens had a wonderful new version, Snap 7, and the palette creation, and so isn't necessary in future. We can use this now in future, and I tried it out this morning. It works good. And I think we had the same intentions to work with the actual version of Snap. And this is the only idea, it's not new. If you start Snap, you can only drag and drop the starter file to create the palettes. And if you have done this, in the second step, you have to load the libraries. And I think nobody is in need for all libraries for one project. But to test it, I put all together in one file, and that's the SciSnap. There are the loaded libraries to the palettes and nothing else. So you first, I can share my window. What can I do this one? Yeah. I try. Can you say and see anything? Oh.
Yes. Yep. Yep.
That's nice for you. I don't see anything on my screen now. It's an interesting session.
It's
and what can
Hilberto.
I do now? I can...
Schrödingero.
What can I do to see my... Okay, I work with my screen. Can you see my screen?
Yes.
Yeah.
Okay. And
but you can't hear us, right?
To a normal... So normally I have a link in my favorite palette, and I start SciSnap automatically. I describe this in the manual, how to do this. And oh, yay, yay, yay. Now I have the starter file and activate JavaScript and create the palettes. And now I can load by drag and drop. Get SciSnap now. Here is it. And open it. And normally in some seconds, and I think in such a meeting in some minutes, it will start. That's all. I think you are only some persons, so does it work? I think it's not necessary to.
Works for me.
I missed which file from the zip to drag.
Would be a good idea if Yadgar starts the video and I try to connect to the session again. Okay.
Yeah. So the files that you were supposed to open, so there was one zip folder that is called SciSnap, and I think that one contains the SciSnap starter XML. So you can just drag that one. Maybe let me just share my screen and I'll show it again.
I see it. Thank you.
Continue. So there's the SciSnap starter in that folder, and you just drag that into a snap window. And then you click on switch to SciSnap, and then you turn JavaScript extensions on. And then you click on SciSnap, and then you get all those new categories in the palette, but they are not filled with blocks yet. And then you did get another project. You can either load all those libraries at once. This is the SciSnap all libraries project, or you can just load single libraries and just drag one of these other files in there. So for example, we could load the data library, and then we get blocks in the data category, but the rest of the categories would still be empty. Okay, so I'll now share the next part of the video till 8:52. Where did I put the video though? Here. Okie dokie.
I want to order some t-shirts for the students of a school or university, and I know how many students there are, but I don't know the distributions to small, normal, and large t-shirt, and I want to find it. So I need some data. I know the ages and the sizes of some people here. Peter is 10 and has a size of 130 centimeters. Paul is 13, 160, and Mary is 16 and 170, and so on. And I find a block in the math category, the polynomial interpolation for some data, and I do this for this data and get the coefficients of a polynomial, but I don't know whether it's a good polynomial for my purpose. I can calculate the values in other points, for instance, for 4. And I use it now to draw the graph or to plot the graph of this polynomial. So I configure first sprite or the stage. I'm working on the stage. Hilberto has no scripts till now. I'm working the stage and configure the stage to a plot pad. I don't see too much now on reaction, and now the next try is to add a graph of this polynomial to the ringified slot of the graph, and I try it, and I don't see only a straight here. That's not so nice. The reason is simple. The ranges, the predefined ranges in the properties are from -5 to 5 and -5 to 5, and I used better values from here from 10 to 20 for the ages and 100 to 200 centimeters for the sizes. I change the ranges now and plot again, and then I get a smooth line for this polynomial, and I can add axes and scales. And now I have a nice diagram. And I combine it. I first have to configure the sprites, then I can set nice ranges for this problem. If I want, I can add some labels to the axis and to the diagram, then I plot the graph and add axes and scales, all on this sprite, the stage. I do it and have my graph.
Okay, I think that's the first example that we want to do together. Eckart, are you back? Okay, then maybe let's just do it together.
Can you hear me now?
Yeah.
Great, and I can see you.
Can you also hear us?
Yes.
Can you hear us?
Yes.
Yay!
Great.
Two
Okay,
things
so
work, but I have no video.
Yeah.
You can't have everything.
Anyways, yeah. Can you share your screen and we walk through the example together again, because the solution doesn't work that we provided for you?
Yeah, that's the next problem. As far as I see, I've copied a broken file. And the question is, we spent some time to get the techniques working out till now. Is it necessary for you to do this?
And I think it would make sense to program one project together. So maybe let's just do that one, and then we can watch the other projects.
Okay. Okay, let's make a variable. You
need to share your screen first, Eckart.
Yeah. Yeah. Did anything happen?
Yeah.
Okay.
Yeah, we see your window. Yeah.
Okay. Let's make a variable. I don't know what I used in the video. Let's take data. And as far as I see, we used set data to list and added some other lists from maybe, yeah, I can do it here. And what's the sequence? Age and size, I think. I don't know the numbers I used in the video. Maybe something like this. The next is 12,
and it's grown a bit. 150. And 13, oh, a bit old. 1. And 18 and 160 or so. So I have some data, and the math category is divided in some parts. There is a collection of libraries. The first intention of me was to create a lecture for math for computer scientists, for teachers. And I don't want to use too much proofs, but use algorithmic to teach a computer what I've learned. And as normal beginners in computing use always the same complexity of algorithms. Either they use a sequence of blocks, or they use a single loop, or at most 2 nested loops, and there are some alternatives. If this happens, then do this. And if you have a look on computer science books from 1970, and now, you don't always find the same examples. Almost nothing happened in the examples learning to programming. And if you want to deal with relevant problems, the only chance is to have more powerful blocks. That's the idea, and it's not new. All the libraries from all computer languages do this. And we have here complex, and then we have a set of linear algebra. You can solve equations there. And one block is polynomial interpolation for points, and we want to do it for data. And where are the variables here? And I get a polynomial for this through this data, and I can see anything from this coefficients here. So I try to configure any sprite to, we can take Alberto here, to a sketchpad for graphs in this case. A sketchpad because I want to draw anything I need to this pad. And if it's too much, I clear it and try it again. So I use the image pad, and in the first version, I used local blocks for the different types of sprites, but to call it from outside is rather leads to a rather complex combination of blocks. And so in this case, I use only global blocks, and I configure anything, any sprite, this sprite, the stage, or another sprite, you can call it by name, and as an image pad or plot pad or graph pad, or whatever you need, or a neural net. And if you use, for instance, Python libraries, you have a lot of parameter to configure the functions you want to use. And so we have the properties for every type of sketchpad, and you only have to define what is necessary in the moment. And here we have, if I want to...
Eckart?
Yes?
Sorry, there was a question whether you could zoom your blocks out in a little bit to make them larger.
Zoom blocks.
Or just zoom the whole thing.
Maybe do 1.5 or so, or 2. Yeah.
Thank
you.
That's a good trick that I can't demonstrate anything after that. No.
Also, if you lower your screen resolution, then for people with small.
Well, no, you can just use your browser zoom to increase your browser zoom. That's even easier.
It's now better?
Much better.
Perfect. Thank you.
Yeah. So I configure this sprite, this is Hilberto, as an image pad. I don't want image pads, I want to plot anything, as a plot pad with size and color, background color. I do this, and now I have an empty sketchpad and a set of variables that are my data to operate with. If I want, I can use every data section I want, and the properties of a plot pad. And I don't have to tell the blocks all of the properties, and they are combined to lists of properties to give it to the other script functions at once. So I want now this, and I can, if I have a plot pad, I can define ranges from the data. I can get it from the range I can define the ranges, and I can use pretty formatted ranges and so, but I do it by hand. I know the plot pad ranges are not good from -10 to 10 because the ages are from 10 to, they should be not. So that this type, and we should set the ranges from, let's say, from 10 for the age to 20, and the sizes from 100 to 200 centimeters. So, and now I change the properties, and then I can anything what I want. I can add a graph, and I can here give a ringified operator or a polynomial. And the polynomial is this. Yes, for plot pad this sprite. And if I do this, oh, I didn't get a good data, whatever, and I can plot this, and I can plot data, for instance, add data plot for numeric data of this data. To this sprite that are the points of the polynomial. And if we want, we can discuss something with overfitting and underfitting, for instance. If I add here a lot of other data to make it better, duplicate, for instance, 70 and this and another one, and oh, empty slots are not so good. We can see if we deal with star spectra, we have a lot of data. It's I have a problem to define polynomials because I have to match points. If I do this and try the same, I get not a usable polynomial. Okay, and in the plot pad, I have a lot of things that I can use. The idea is that the students should create their own solutions from these blocks. Rick Hessman from the astrophysics, I work together with him, always wants to get a ready block to create a diagram. And we had a simple version here for this in this case, but I'm more friend of blocks that are able to do what I want. Yes, and this is an example here also how to create a simple diagram with 5 blocks also. Okay.
Great example. Thanks, Eckart. One question from my side. Do I need to order the input before I use it in the plot pad? Because now you started with 10 and then did 12 and 13 and 17 and 18. Or can I do that later? Or does it also, I mean, yeah.
Here is a normal polynomial interpolation and the order doesn't matter here.
Okay, great.
But if I draw a line through the points, then it's necessary to order it before.
To order them, okay.
Yes, and
good.
Yes, but it's no problem. In the data here, you can sort anywhere with the subjects. And here's a lot of extra for you, Levenstein distance for DNA sequences.
Oh, great. I didn't have time to look at that, but will do. Okay, so I'll share the next example in the video if you don't have any questions for that example. Okay.
I have a very stupid question probably. Okay. I'm not getting the labels and everything. I think I missed one step.
Yes, if you have a look on the plot palette, there are here set plot pad labels.
Okay, now I see it. Thank you.
Diagram title, and you can text hide and so on.
Okay. So let me share the next part of the video. That's 2:13:05. Wait, stop sharing. I didn't share with audio, I think. No. Okay.
Now I want to create some data, and I want to plot here data, and I can create data here with blocks from the data category. And the good block for this purpose is to create an points near a function. The function here is a polynomial, and I can, I have to put it here, and between 10 and 20 that are the values from the ages, and I can give a range. Let's give 20 centimeters. And I now produce 100 random datas, and this data I can plot in the same on the same plot pad. Set plot pad properties to square and width and so on, color. Color may be black, okay. And then set data to this random points, and then I can add a data plot of my data. I used my data as data area to this sprite. So this script creates enough data to test what sizes are needed. I do it in the next attempt. Now my data are the black squares here in the graph, and I do 3 means clustering for my data with Euclidean matrix. That's not the best idea, but I use this block. There is another block here, anywhere here. I can define another clustering with my own matrix. You should do it after this. I set my data now to 3 means clustering, and I have all my data here and assigned it to one of the 3 clusters. And I change my data now to cluster data and want to show the result. And the result is I will plot this data in different colors. So I select the rows of my data where column 3, that is a cluster number, is equal to 1. This gives me all data of cluster 1. That are these. I can see it with 1. And I define the color to red, 255.255.00, and add this to the diagram. These are these points, and do the same now with the cluster 2, and the color for this cluster should be green. I do it. And the same for cluster 3 with color blue. And it works nice. The small ones are here, the normal ones are this, and the tall ones are this. Now I want to determine how many t-shirts do I need from the different sizes, and I can do it with one of these blocks here and count the data of the different groups. But to demonstrate it, I will give some orders to Hilberto. I want to use another side to show a diagram. So I define variable sizes and want to show a histogram of this data from Hilberto. So for histogram, I only need the third column of my data, that are these, the cluster numbers, and I assign it to sizes. And now I give some orders to Hilberto, also tell Hilberto to configure this sprite, Hilberto, to a plot pad, and he should add a histogram from this data sizes with 3 groups. There are 3 clusters, pretty formatted, and that looks nice now then, and add axes and scales like here. And I give this command to Hilberto, and then I have a histogram, and I can find here the small ones are about 15, 18 or so, 35 from normal, from middle, and large should be 45. The second example.
Sorry. Okay, so let me stop screen sharing, and we're already running out of time, but maybe you need 1-2 more minutes to explore the plot pad sprite, and then we go on sharing the next example. And Eckart, maybe there's a question for you. Matthias gets an error. A custom block definition is missing. In which block, Matthias?
No, as far as I've seen, all they are missing. I have copied a broken file as far as I see.
In the solutions, yeah.
Yeah,
Okay.
yeah. The other files work.
Okay, thank you.
I think I've copied the file to normal snap, and all the blocks doesn't exist. And shit happens. I think it's not, Yatka, let's continue. We don't have too much time, and
Okay.
I think it's no time to reconstruct all this.
Okay, then let me share the screen again. And let's go on to the next example.
Deals with graphs. I have a graph pad, and on this graph there should be a structure of vertices and edges. And in this case, I will try to build a graph that acts as a learning perceptron. We have two sprites, Hilberto, and I'm on the script level of Hilberto now, and Alberto. Alberto will be configured as a perceptron and should work like a perceptron. First, Hilberto sees that he is alone, and he creates a duplicate of himself and calls it perceptron. That has been done before, and now Hilberto has to configure the perceptron as a graph pad. He does this and sets some properties for the edges and the vertices. The vertices should show the content, and the edges should be directed and weighted. They have weights. And now we have the graph pad and the properties of the desired graph. First, I create some vertices on this graph, and I've created 3 input vertices, the center, the main operation center, and an output vertex who shows the result. And now I connect the vertices with edges from the input neurons to the center and then to the output. I do this. In the beginning, there are random values and as weights of the edges. I change these weights to in an appropriate range. And after that, I calculate the output of the perceptron. This be done if I multiply the value, the content of a vertex with the weight of the connected edge, and the result goes to the center, is summed here, and if the result is bigger than 0.5, the output will be 1, else minus 1. And if this is done, I add 6 vertex. When I click on this vertex, I can show the desired result of the perceptron, that the perceptron should learn to produce this result. And now I can write something, some command on the stage and start working. Now the perceptron shall learn. I switch to the perceptron, and I did this in the following way. When I click on the perceptron, I first try to find out whether I've met a vertex or not. That can I do with a block vertex number at mouse position on this graph. If I get a number, I look whether I met input vertex or this result vertex. If this is the case, I change the content of this vertex and calculate the output new. And if I've clicked anywhere else, the perceptron should learn to produce the desired output here. And now some examples for the task of the workshop. First, we want to configure a neural net. I can do it by configuring any sprite, define the dimensions of the net, and show the status with some inputs. Here are random values, and the values are color-coded at the edges and vertices. Here only random numbers are used, and now begins the training. The net should be trained to the output 1, 0, 0, -1. And the training begins, and the colors are changing, and here I have -1 and here I have 1. Next example, we use a Taylor approximation, a Taylor series, to express the angle of a mass pendulum, and draw the graph of the real angle and the approximated, and the result is we have some differences between the black and the red line. I stop it now. But if I expand the number of the terms of the Taylor series, I get a better result. Next example is about the spectrum of stars. We can load some star data, and the main job is to prepare the data for a nice diagram. I've loaded some star data, and I will show the spectrum in a plot pad. This is the result. And I used block to normalize this data, the original data, by mean. And if I want, I can calculate a polynomial to approximate this data, and the coefficients of the polynomial can be used to determine different star types by a neural net. I also can compress the data to find some characteristics, and here I can use the block compressed with factor by averaging. I want to display the graph of some COVID data. At first I have to import some data from a spreadsheet in this case, and set data to a part of this data with the German data. And because I only want numbers, I delete the first row of the data. Now I configure Hilberto as a plot pad and display this data. And to find a result about the development, I add the logarithm of the data to this table and replace the second column by this. I do it now, and now I can display the regression lines for the beginning of the pandemic and the end, and at this time of the development we thought everything will become great. Now I want to measure a bit with a mouse, and I want to measure the shadow length of a moon crater. I configure Alberto is the physician, to image pad and load an image. I've done this, and now I import the image data to my data area, and what I can do, for example, I can change it to false color image but I don't want it. And now I want to do a slice through this image. That I can do, I can get the slice data by mouse. I try it here, and now I can get the slice data. I got it, and I prepare them a bit by averaging and compress it. And now I can use another sprite to plot the graph of this data, that are these. So last example, I will use the SQL library, and I have to configure the system to SQL and connect to a database server. And now I can read the databases available, and I choose the second one, and I can perform SQL queries to this database. I want to get the names and the results of different students grouped by name and ordered descending. I try to get this to execute this query, and I can import the result to the data area of SQL. So folks, we are ready with the examples. I've prepared some tasks for them. For each there is the example program and the data if necessary. Get to work and have fun.
Okay, so I'll stop screen sharing, and we have 5 more minutes left. You can either ask more questions, or you can spend the rest of the time exploring the examples.
Or we can have a discussion.
Yes. Sorry.
If we have time, maybe I can illustrate what I want. If I use the graph pads in schools and also in university, in computer science, we have a lot of applications with graphs. And normally it's a problem for beginners to draw the das Bild ist wieder weg. To draw the vertices and the edges and the arrow and the end of the edge, and so they are. It's too much to do this. If I want to do yes, and I think it's a difficult problem for beginners to draw an appropriate graph image. If I use here a graph pad, I can I use graph example here for small worlds. That's it. I can edit with only with only 3 commands here. With 3 blocks, I create a graph pad at 100 vertices and 100 edges. And I think to draw this is very hard for a beginner without help. But what I can do here, blocks a list of all shortest paths from a vertex to all others. That's a normal Dijkstra routing on graphs. And if I have this block, I can calculate all the means of this and can, for instance, calculate the mean of the distance of two vertices on this graph. And then I have a lot of problems deal with this. So I can security of networks or social I can customer and what's that Firmen und Lieferantenbeziehung. You can find a lot of applications for questions which are related to the connectivity in such a graph. In the video, I use another form to define the graphs for a perceptron, and you can build family trees or something like that with this set of blocks. And the scripts are in the complexity real simple. 1, 2, 3, 4, and nested command, and you can spend the time with the question, what does it mean? I'm ready.
Okay, Mary asks whether we can take a short look on the linear algebra blocks. We have like 2 or 3 more minutes left, so maybe you can show these.
Yeah. Linear algebras, you can define vectors and matrices and so, and can transpose it. That are operations. I built this because I think the operations from SNAP are very, very friendly to the users and in linear algebra. And I'm an old teacher, and I think if you have multiply a matrix with a vector of wrong dimensions, you shouldn't get a result, but an error message. And that was the reason I built this in. You can linear operations or all the operations between vector scalars and matrices. Polynomial interpolation we can apply matrix to a set of points and to manual in geometry to deal with squares and triangles and other objects defined by point list. You can solve this equation, linear equations in linear algebra, apply the Gauss method to a matrix to solve it or to find everything you want. That's the linear algebra blocks. And here,
how do you define a vector? Mary wants to know. Can you maybe show the vector block real quick?
Only as a list. Add it.
Okay, great. Okay, and you can add more numbers. So, for example, a 3-dimensional vector or a multi-dimensional vector.
Yeah.
Vector addition. She's asking about the vector addition, she says.
Vector addition is a linear operation.
Wow.
Well, that was fun.
I think we lost Eckart. But
I guess the workshop's over.
Might be. Don't forget to take a look at Eckart's document. I posted it again. It also has explanations for most of the libraries and a lot of examples. So maybe just check this out. And